Everyone, welcome back to part 3 of opencv. In this video we are going to be talking about how do we process videos and how do we put in effects on our videos. So that's what we are going to do. Until now we have discussed about image processing, reading an image, reading video file, and we have also seen how to put in effects, computation, how do we do that for images. And in this video I'm going to be showing the same for you but for videos. So the first step, as I've shown you earlier, you just have to import CV2. You can import it as CV2, but as I said earlier, I'm used to CV, so that's what I'm going to be doing. So you can just give an initialization. You can just give any name here. It's not like you have to use cap only. I can just show you. If I could use some like top, they are just random names I'm getting, so you can just keep on giving any names here. Video capture, and you have to give the file name, okay, the video file name. So this is where my file is, forest.mp4, you can see. So that's what I'm going to be doing, forest.mp4. This is going to be an infinite loop basically. So while true, we first check the condition. If it is true, then we execute. Okay, as I've shown you earlier, and you have to read what you have just uh, seen. So cap.read, and now you have to display your image. So I'll say forest. You can give any name here, and img. Oh, sorry, img. So now we need to give some weight key. This is the most optimum value, as I've shown you earlier. If you don't want to do this, then you can just try around, play around different values to find your own. Okay, so cv.weight key 20 is the most optimum value for video processing to make your video more smoother. Okay, so you can have to break the loop for this condition. I have explained all these in my previous videos. If you are not able to understand what I'm doing, then please do check out my previous videos. Now what you need to do is release the values that you have just stored. Okay, so cap release, then we just show all the windows. Okay, so now if I just run the code, wait for some time. Okay, that's quite a large size, so we'll just resize this. img is equal to cv dot resize img, then up to the grade you need to resize this 400, 600. That's just the random value I'm giving to try out. Or no, I have to increase the width, so I guess 600 by 600. Okay, it would be too small, I guess. So 800. Sorry, I have a sore throat today. So no, I don't think it's fine, but I'll just keep it to 600 and see. There you go. You can see this is my video. If I want to make it black and white, then I can just do that using computer vision, or if we can just put in a lot of effects in this. Okay, so I'm sorry. We'll do one thing. BNW is black and white. So cv dot convert color and give your image address, and cv dot color underscore bgr to gray, and we will read black and white image instead of this one. Okay, so BNW save, run the code. Now see, our video is in black and white conditions. This is how it works. You can just play around different effects that we have got. We can even blur this using Gaussian blur, as I've shown you in my previous videos. And let's just type for HSV color underscore. First just try for BGR to RGB. Okay, let's just give for HSV first, and you can just change these, or else you can just keep it this way. You can say this is how our HSV looks like. So basically this is how control detection is done. I'll show you how do you do that for canny edge as well, to detect edges. For self-driving cars particularly, you could see the lane in between, right? This lane. Okay, so this lane is detected using contour detection. Okay, we basically do some computation with canny edge, and we set the kernel value to the most optimum result, and then we detect these lanes and guide our vehicle basically to keep itself on the lane. Okay, so it makes sure that, yeah, it is not crossing those boundaries that you have set using control detection. So this is how it works. So that's the end of the video, and let's just try for some of the values like BGR to RGB. Let me just show you this. This is going to be really exciting. BGR to RGB, save and run. There you go. You can see certain differences in color here. You can see this lane is like bluish white color, and this color. Let me just run these two values side by side so that you can identify the difference in them. Let's just reduce the size so that I could keep them side by side. Yeah, there you go. Run the code. Now you can 1 second. Uh, we have computed the size. 1 second. Q. 1 second, guys. Forest. I have to give another name, so forest underscore original. It doesn't matter actually, but let's just keep it this way. Run the code. There you go. You can see the difference among these two. So that is how the difference is. You can see this green color is particularly staying a major difference in RGB format. We do that because in certain like in certain platforms, on certain platforms that we do with computer vision only accepts RGB format files, okay, but computer vision works on BGR. So that's what the difference is. You can see these mountains difference over here. This is like more whitish in color, and here you see it clearly shows us that there is sunlight falling upon. So particularly this lane, you could see this is yellowish in color, and here you get it in white and blue maybe. And of course the color of the trees are also completely different. And let's just try around for canny edge. Okay, so can is equal to cv.canny edge detection img comma threshold one value you have to set as 7. Threshold 2 is equal to 7, and that's it. So run the code. Oh, 1 second. There's some kind of error I'm getting. 700 from 500 revise is empty function. We will read canny as well. So can run the code. So you can see this is how, okay, so basically the kernel is like too high, the threshold is basically too high for it. So we just play around these values to get that most optimum result you could get. Let's just keep the threshold to 23 and make it a little smoother. And look, you cannot get the optimum result just by dealing with canny. Okay, let me just show you how do you do that. I'll just read canny file, not an original file now, because it is giving it takes a lot of effort from the processor. You must have a GPU in order to read such files and see such multiple video effects. And yeah, I have to give some blurring effect. So blurring is equal to CV on motion blur is the most widely used one. So img comma kernel size is 7,7 and run the file. Oh, sorry, I missed the sigma x value here. So sorry. Yes, sigma x is equal to like 5 maybe. Let's just, yeah, it's still not working. So let's just increase the kernel value to 23. I'll make a whole dedicated video for kernel, what kernel is. I'll explain it to you in the coming videos. You will see a difference in this if I just play around these values. Okay, I'll explain everything of this. You can see more edges are now being detected, and if I just reduce it like 3,3, you see uh oh, sorry, I have to play with this as well. Yeah, one maybe. This area particularly is being a little smoother this time, so like 123 and 123. Let's just take it as 123 and see what difference does it make. So a lot of edges are being detected as you keep on playing with these values. A lot of edges are being detected actually. So you can see these many edges. So I'll explain how do you compute canny edge and how do you put in the blur effects basically to make your images more readable and to get that control part that you want. Okay, and I'll explain in the next video how do you deal with one particular detection in a video. So let me just show you what I'm trying to say. Car.mp4, let us read this car.mp4 file, and Yeah, that's what I'm gonna do. Let's mute this one. Sorry, comment down and run the code. So in this video, oh, you can see this. I have converted this to BGR. So one second, guys. Yeah, you can see this. This is in BGR format, and this is the original color. You could see this red color is now converted into blue because BGRP is R now. So that is how it works. And this blue color is actually quite light in color, so they have converted it into more like an oranges golden color. I'm not sure what kind of color is that, but yeah, that is completely an RGB format. So that's how it works. In the upcoming video, I'm going to be showing you guys how do you detect this car particularly in real time. We will use some contour detection methodology. Let me just show you how. We will play around canny edge detection in order to do that. So let me just comment down rest of the values and run the code. So you can see this is how an autonomous car sees the world. Okay, this is how it sees. So we basically blur this image and remove all these excessive edges that we see using some computation with Gaussian blur or any other blur methods. I'll explain how many blur methods are there and which one do we use most often. I'll explain it to you in detail in the next video, in the upcoming videos basically. And in the next video, I'm going to be showing you guys how do you detect a car in real time. Okay, we will do some computation part with canny edge and we detect this car and we try our best to remove all these excessive edges being detected. So do subscribe to my video and wait for the most exciting videos to come. Up to now, we have discussed the kind of video and image processing we usually do in computer vision, and in the next videos, as I've told you earlier, we are going to be talking about detections, and I'll explain you about numpy, kernel, and which blur effect do we need to use and how do we get the most optimum canny edge value. I'll explain it to you everything in a completely dedicated video. Okay, so those videos are not going to be included in this playlist because this playlist is completely dedicated for computer vision only. I'll explain you about NumPy and kernel in some other videos. Those are going to be coming very soon. So do subscribe to my video and thank you so much.